Hello learners, welcome back. I am Rajat Tiwari, lecturer, University Teaching Department, Chhattisgarh Swami Vivekanand Technical University Bhilai, and your subject matter expert for this course. In today's session, we will be exploring the topic of leveling, focusing on numerical on height of collimation and rise and fall method. We will delve into practical numerical to solidify your understanding of how levels are reduced in real world scenarios. We will be discussing firstly the numericals on height of collimation method and the numericals on rise and fall method. So, as we have already discussed about this topic in our previous session in detail. So, we will solve different numerical related to both of these methods. Let us take first example. In this, the following readings were successfully taken with an instrument in leveling work, that is 0.32, 0.53, 0.62 and so on up to 0.98 meters. In this question, the position of the instrument was changed after 3rd, 7th and 9th readings. We have to draw out the form of a level book and enter the above readings properly. Assuming the reduced level of the first point as 81.53 meter, we have to calculate the reduced level of all points and apply the usual checks. So, let us start. Since as we know the instrument position was changed after the 3rd, 7th and 9th readings, we will categorize all these readings into backside, intermediate side and foreside based on the information provided. Let us go through the process step by step. The first reading, that is 0.32 meter, must be a backside reading as it is the first reading at the starting station. The instrument was moved after 3rd, 7th and 9th reading, making them as the foreside readings at the change points. The reading following these foreside readings after the instrument change must be a backside reading. From this information, we can easily fill the required field level book with these points. So, we will solve this question first by rise and fall method. So, steps involved using the rise and fall method would be, firstly we will identify the back side, foreside and intermediate side. So, the back side, that is the first reading after each instrument setup change. So, in our question this will be the first, 4th, 8th and the 10th reading. For the foreside, that is the last reading before each instrument setup change. So, these will be 3rd, 7th, 9th and 11th readings, and all other readings would go under intermediate side. So, we will fill this field level book according to the information. So, back side will be 0.32, then next intermediate side would be 0.53, next foreside would be 0.62, and since after this there is change in the level instrument. So, we will go to the back side again. So, 1.78 will be the back side. Next two reading, that is 1.91 and 2.35 would be intermediate side, and the next reading would be 1.75 just before the change of the instrument, and after the change the next reading would be 0.35, that is back side, and the next reading would be 0.69 since before the change of the foreside, and after the change, that is 1.24 would go under back side, and the last reading would always go under foreside. So, we have filled all the details. After that, we will calculate the rise and fall between consecutive points. We will subtract the current reading from the next reading to determine whether there is a rise or a fall. If the result is positive, it will indicate a rise. If the result will be negative, it will indicate a fall. After that, we will calculate reduced levels of each point. We will add the rise or subtract the fall from the reduced level of the previous station to get the reduced level of the current station. And after that we will perform arithmetical check. So, arithmetical check for the rise and fall method would be sigma backside minus sigma foreside should be equal to sigma rise minus sigma fall should be equal to last reduced level minus first reduced level. So, we will solve accordingly. We will move from station A to station B. So, there is backside have been given to us as 0.32 meter as we have jotted down in our field level book at station A, and the intermediate side is jotted down as 0.53 meter at station B. We will subtract 0.32 and minus 0.53 which will result in minus 0.21 meter. So, it comes negative. So, it will indicate a fall, and for calculating the reduced level at B, we will subtract the reduced level at station A with the fall. So, 81.53 minus 0.21 which will be equal to 81.32 meter. So, reduced level at B will be 81.32 meter. Moving on from station B to C, intermediate side is 0.53 at station B and fourth side is 0.62 meter. We will subtract 0.53 minus 0.62 which will equal to minus 0.09 meter. Again it is negative, it will indicate a fall. So, for calculating reduced level at C, it would be reduced level at B, that is 81.32 meter minus the fall, that is 0.09 meters, which will be equal to 81.23 meters. Moving on from station C to station D, that is the change point 1. So, backside here, backside is 1.78 meter, since it is after the change point at station C, and intermediate side is 1.91 meter at station D. So, we will subtract 1.78 minus 1.91 which will result in minus 0.13 meter. So, again negative, it will indicate a fall. So, for calculating reduced level at D, the reduced level at C minus the fall, that is 81.23 minus 0.13 which will be equal to 81.10 meter. Moving on from station D to E, intermediate side is 1.91 meters, and again intermediate side have been given as 2.35 meter. So, we will subtract 1.91 meters minus 2.35 meters. Again it will give a negative value of 0.44 meter, that is represent fall. So, reduced level at E would be 81.10 minus 0.44 which will be equal to 80.66 meter. Moving on from station E to F, intermediate side is 2.35 meters and fourth side is 1.75 meters. So, we will subtract 2.35 minus 1.91 which will result in plus 0.60 meter. So, here the value comes in positive which will indicate it is a rise. So, for calculating reduced level at F, it will be reduced level at E plus the rise, that is 80.66 plus 0.60 which will be equal to 81.26 meter. Now, from station F to G, back side is 0.35 meter at station F and fore side is 0.69 meter at station G. So, we will subtract, that is 0.35 minus 0.69 which will be equal to minus 0.34 meter, that is a fall. So, reduced level at G would be reduced level at F minus the fall, that is 81.26 minus 0.34 which results in 80.92 meter. Moving on from station G to H, back side is 1.24 meter at station G and fore side is 0.98 meter at station H. So, we will subtract 1.24 meter minus 0.98 meters which will be equal to plus 0.26 meter. Since it is positive, it will indicate the rise. So, reduced level at H will be reduced level at station G, that is 80.92 meter plus 0.26 meter which will result in 81.18 meter. So, reduced level at H would be 81.18 meters. Now, we have calculated all the RLs of each stations, and now we will do an arithmetical check to give an accurate result, or what we have done in previous slides is correct or not. So, sigma backside minus sigma foreside is equal to sigma rise minus sigma fall, which should be equal to last RL minus first RL. So, sigma backside is total given as, or calculated as 3.69 minus sigma foreside has been calculated as 4.04, which will be equal to 0.35. Sigma rise have been calculated as 0.86 and sigma fall has been calculated as 1.21, and last RL and first RL has been calculated 81.18 minus 81.53 meters. So, all are equal, and it gives a result equal to minus 0.35. Hence, we have checked the arithmetical checks which have been introduced in rise and fall method. Hence, our calculations are okay. Now, after rise and fall method, we will move on to height of collimation method. So, steps to solve using height of collimation method include: firstly, we will identify the back side, foreside and intermediate side as discussed earlier, and in the second step we will calculate the height of instrument, and the height of instrument is calculated by adding the back side to the reduced level of the previous station. So, height of instrument would be reduced level plus the back side, and after that calculation of reduced levels for each subsequent point. We have to calculate the reduced level by subtracting the intermediate side or the foreside from the height of instrument. So, reduced level will be HI minus IS or HI minus FS, and then in the next step we will apply usual checks, but in the height of instrument method the checks have been given as sigma backside minus sigma foreside, which should be equal to last RL minus the first RL. So, we have jotted down all the readings, that is back side, intermediate side and foreside, as have been discussed in the previous slides, and now we will calculate the reduced level and height of instruments. For station A, that is the back side have been given as 0.32 meters, and reduced level at station A have been given as 81.53 meters. So, we will calculate the height of instrument as back side plus reduced level, which will be equal to 0.32 meters plus 81.53 meter, which will be equal to 81.85 meter. Now, the reduced level at station B can easily be calculated as height of instrument minus the intermediate side, that is 81.85 meter minus the intermediate side as 0.53 meters, which will be equal to 81.32 meters, and the reduced level at station C would be height of instrument minus the foreside, which will be equal to 81.85 meter minus 0.62, that is 81.23 meter. So, as we know, after this foreside reading there is shift in the instrument, which will result in the new height of instrument. Now, in station C, that is the first change point, this point is marked as change point because the instrument is moved after this reading. So, back side here would be 1.78 meter. So, new HI would be reduced level at previous station, that is station C plus the back side. So, 81.23 plus 1.78, which will be equal to 83.01 meters. Now, with this new height of instrument, we can easily calculate different reduced level up to the point where instrument is shifted next. So, reduced level at station D would be height of instrument minus intermediate side, which will be equal to 83.01 minus 1.91, which result in 81.10 meters. Next, reduced level at station E will be equal to height of instrument minus the intermediate side, which will be equal to 83.01 minus 2.35, result in 80.66 meters. And next, the reduced level at station F will be equal to height of instrument minus the foreside, which will be equal to 83.01 meter minus 1.75 meter, which will result in 81.26 meter. So, now as we know, after this foreside reading there is a shift in the instrument again, which will result in again the new height of instrument station F, that is the change point 2 station. So, back side have been given there as 0.35 meter. So, new height of instrument would be reduced level at F plus the back side, that is 81.26 meter plus 0.35, which will result in 81.61 meter. Now, reduced level at G can be calculated as height of instrument minus the force side, that is 81.61 minus 0.69, which will result in 80.92 meters. Next station G, that is change point 3, here back side is given as 1.24 meters. So, new height of instrument would be reduced level at G plus the back side, that is 80.92 plus 1.24, which will result in 82.16 meter. Now, reduced level at station H can be calculated easily as height of instrument minus the force side, that is 82.16 meter minus 0.98 meters, which will result in 81.98 meter. And the arithmetic check in this height of instrument method is sigma back side minus sigma force side, which should be equal to last reduced level minus the first reduced level. So, sigma back side have been calculated as 3.69 meters and force side have been calculated as 4.04 meter, which will result in minus 0.35, and the last RL calculated as 81.18 and the first RL is calculated as 81.53. So, subtracting 81.18 minus 81.53, which will result in minus 0.35 meter. Hence, our check is OK. Now, in the second example, the following consecutive readings were taken with the level and a 4 meter staff on a continuously sloping ground at a common interval of 30 meter have been provided as 0.780 meters, 1.535, 1.955 and so on up to 2.545 meters. The reduced level of the first point A was 180.750 meter, and we have to rule out a page of level field book and enter the above readings. We have to calculate the reduced levels of the point by collimation system and rise and fall system. Also, we have to calculate the gradient of the line joining the first and the last point. So, the first reading, that is 0.780 at station A, must be backside reading. In the previous question, it has been already speaked about shifting of instrument, but in this question we have to identify it. So, since we know the readings were taken on a continuously sloping ground with a 4 meter staff, so the largest reading that can be taken would be the 4 meter. Therefore, the position of the level must have been changed after the largest reading of each series, such as after 3.480 you can see of the first series and after 3.640 of the second series. So, the last observation of 2.545 must be force side reading, as you know. Hence, and the observation 3.480, 3.640 and 2.545 are booked in the force side column. Each of the force side readings 3.480 and 3.640 are the change point. So, at the change point are preceded by backside reading, that are 1.155 and 0.935 respectively. So, all the remaining readings would go under intermediate side reading, as you can see in this field level book. So, we have different columns in which first column is station, second is for distance, and third that are regular intervals of 30 meters. Third would be of reading, that is back side, intermediate side and force side. We have already jotted down all the readings as discussed in the previous slides. Next is the height of instrument, which we will be calculating, and we will be calculating reduced level of each of the points. So, in station A, as we know, distance is 0 meters. So, we have been given the reduced level of station A, that is 180.750 meters. So, what we do? We will calculate firstly the height of instrument. So, height of instrument would be the reduced level plus the back side, that is 180.750 meter plus 0.780 meter, which will result in 181.530 meters. With this height of instrument, we can calculate easily the reduced level of the up to the point where the instrument has not been changed. So, we will calculate for the distance of 30 meter, the reduced level would be the height of instrument, that is 181.530 meter minus the intermediate side, that is 1.535, which will result in 179.995 meters. For the reduced level for the distance of 60 meters would be the height of instrument, that is 181.530 minus 1.955 meters, which will result in 179.575 meters. Now, for reduced level of up to 90 meters would be height of instrument 181.530 minus 2.430, which will result in 179.100 meters. Now, for the reduced level up to 120 meters would be the height of instrument, that is 181.530 minus 2.985, which will result in 178.545 meters. Now, as we know, there is change in the instrument. Again, we will calculate the reduced level for the foresight as height of instrument minus foresight, that is 181.530 minus 3.480, which will result in 178.050, that is the reduced level of distance up to 150 meters. Now, as we know, there is change in the shifting in the instrument after this point. So, we will again calculate the new height of instrument for this station, which will be equal to the reduced level up to 150 meters, that is 178.050 meter plus the back side, that is 1.155, which will result in 179.205 meters. So, this is our new HI which will be helpful in calculating the next RLs. So, next RL of at 180 meters would be 179.205, that is the height of instrument minus the intermediate side 1.960, which will result in 177.245. And in next for 210 meters, it would be equal to 179.205 minus 2.365 meters, which will result in 176.840 meter. Next RL at 240 meters would be 179.205 minus 3.640, which will result in 175.565 meters. Again, we have to calculate the new HI, and it would be equal to the reduced level at 240 meters, that is 175.565 plus the back side, that is 0.935, which will result in 176.500 meters. Again, we can easily calculate the RLs of next two that are 270 meters, RL at 270 meter, which will be equal to 176.500 minus 1.045, which will result in 175.445 meters. Again, RL at 300 meters would be 176.500 minus 1.630, which would result in 174.870 meters. And the last RL, that will be equal to 176.5 minus 2.545, which will result in 173.955 meters. And after this, we can calculate the checks, that is sigma backside minus sigma foresight, which will be equal to 2.780 minus 9.665 meters, which will result in minus 6.795, and the RL of last point minus the RL of first point, that will be equal to 173.955 minus 180.750, which will result in minus 6.795 meters, and both are equal. So, our calculations are okay. Now, we will again calculate with the rise and fall method. As you can see, all the columns, we will again strictly go to the calculation part. So, reduced level for the station A have been given as 180.750 meters. So, we will subtract firstly the back side, that is 0.780 minus with the one intermediate side, that is 1.535, which will result in minus 0.755. So, as we know, minus indicate the fall, so it will go on the column of fall, that is 0.755. So, we can easily calculate the reduced level as the reduced level of previous point, that is station A 180.750 minus the fall, that is 0.755. 755, which will result in 179.995 meters. Again, we will subtract 1.535 minus the 1.955, which will result in 0.420. So, and again we will subtract 1.955 to 2.430, which will result in fall of 0.475, and again we will subtract 2.430 with 2.985, which will result in the fall of 0.555, and again we will subtract 2.985 with the foresight of 3.480, which will result in fall of 0.495, and we have to be careful about this point, and after that we will subtract 1 point, that is back side, because there is change in the or shift in the instrument. So, we will subtract back side with the intermediate side, 1.155 minus 1.960. So, which will result again minus value. So, it will go into category of fall, that is 0.805 meters. Again we will subtract 1.960 with 2.365, which will result in the fall of 0.405, and in the next we will subtract 2.365 with a fall of 3.640, which will result for the foresight of 3.640, which will result in fall of 1.275, and again there is change or shift in the instrument. So, we will subtract back side with the intermediate side. So, 0.935 will be subtracted to the 1.045, which will result in 0.110, and again 1.045 will go subtracted with 1.630, which will result in 0.585, and again lastly we will subtract, that is 1.630 minus 2.545, which will give a negative value of 0.915, hence it will go in the category of fall. So, we have calculated all the values of fall, and now with this we can easily calculate the reduced level, as reduced level of station A have been given as 180.750. We will subtract the fall 0.755 to get the next reduced level at 30 meters, that is 179.995 meters. Again we will subtract next fall of 0.420 meter to get the reduced level at 60 meter, that is 179.575 meters. Again we will subtract the 179.575 to the next fall of 0.475 meters and get the value of RL at 90 meters at 179.100 meters. So on, we can easily calculate the RL of each and every point, and as it is been shown in this field level book. So, RL at B is calculated as 173.955 meters. Now, we can easily go to the arithmetical check and check whether our calculations are right or not. So, arithmetical check for this rise and fall method have been given as sigma backside minus sigma foresight should be equal to sigma rise minus sigma fall, and should be equal to last RL minus first RL. So, all these readings have been or calculated as minus 6.795, hence our calculations are correct. So, there is continuous fall of 6.795 meter in a distance of 330 meters. So, gradient would be equal to 6.795 meters divided by 330 meters, which will be equal to 1.1 in 48.56 gradient. Answer is 1 in 48.56. So, in the next question, the page of a field level book has been given. The readings in the level book were written with pencil and some of got erased. So, the erased readings are marked with question marks. So, we have to calculate the missing readings. So, this field level book has been given to us. In this some details are missing, we have to find out this reading. So, we will go on. So, the backside reading at station 1 is missing as shown. So, the intermediate station of station 2 is 2.457 meters, and there is a fall of 0.827 meter from station 1 to station 2. Therefore, the back side at station 1 must be less than the intermediate side at station 2. So, the back side at station 1 should be equal to 2.457 minus 0.827. So, result will be 1.63 meter. Next, the reduced level of station 2 is missing. So, reduced level of station 1 is 150 meters, and there is a fall of 0.827 meter from station 1 to 2. Therefore, the reduced level of station 2 must be less than the station 1. So, reduced level of station 2 should be equal to 150 minus 0.827, which will result in 149.173 meters. Next, the reduced level of station 3 is missing. So, reduced level of station 2 is 149.173 meter, and there is a rise of 0.057 meters from station 2 to 3. Therefore, the RL of station 3 must be more than that of station 2. So, reduced level of station 3 will be 149.173 plus 0.057, which will result in 149.230 meter. Next, the fall from station 3 to station 4 is missing. So, reduced level of station 3 is 149.230 meter, which is more than the reduced level of station 4, that is 148.070 meter. Therefore, the fall from station 3 to 4 will be equal to 149.230 meter minus 148.070, which will result in 1.160 meter. In the next, the force at station 4 is missing. The intermediate site at station 3 is 2.4 meter. There is a fall of 1.160 meter from station 3 to station 4. Therefore, the force at station 4 must be more than the intermediate site at station 3. Force at station 4 should be equal to 2.40 meter plus the 1.160, that is 3.560 meters. Next, the back side at station 5 is missing. So, there is a rise of 1.068 meter from station 5 to station 6. Therefore, the back side at station 5 must be more than the intermediate side at station 6. So, back side at station 5 is equal to 2.5 plus 1.068, that is 3.568 meter. The fall between station 6 to station 7 is missing. Since reduced level of station 6 is more, it is higher level than station 7. Therefore, the fall can be determined by subtracting the reduced level of station 7 and reduced level of station 6. The fall between station 6 and 7 will be equal to 149.784 minus 149.388, which will be equal to 0.396 meters. So, the reduced level of station 8 is missing. The RL of station 7 is 149.380 meter, and there is a fall of 0.124 meter from station 7 to station 8. Therefore, the reduced level of station 8 must be less than that of station 7. So, reduced level of station 8 would be equal to 149.388 minus 0.124, which will be equal to 149.264 meters. And lastly, the intermediate site of station 8 is missing. There is a fall of 0.124 meter from station 7 to station 8. Therefore, the intermediate site at station 8 must be more than that of station 7. So, intermediate site station 8 would be equal to 2.896 plus 0.124, which will result in 3.020 meters. Hence, all the missing entries have been identified and entered as shown. So, dear learners, we have reached the end of today's session. I hope you find it informative and engaging. See you in the next class. Thank you.